Our final award today, the Sidney Powers Memorial Award, goes to an AAPG honorary member who is a pioneer of modern geoscience, co-author of the first comprehensive textbook on geochemical process-focused exploration, an outstanding academician and researcher, and a leader in the development of basin and petroleum system modeling. Dietrich Welte, in the words of citationist Brian Horsfeld, is one of Europe's leading elder statesmen in geology and geochemistry. After periods in industry with Shell and Chevron and in academia at Göttingen and Aachen universities, he founded the Institute of Petroleum and Organic Geochemistry at Kernforschungslager KFA, now Forschungszentrum Zulich, in 1979. Following his entrepreneurial instincts, Dietrich founded Integrated Exploration Systems in 1983, a basin modeling company that rode the ups and downs of the industry, which eventually flourished at the leading edge of technology. Having reached retirement age in 2000, Dietrich stepped down from his position as Institute Director at KFA and graduated to Professor Emeritus status at Aachen. But in true style, his horizons remained broad, leading integrated exploration systems to bigger and better things, culminating in the acquisition of the company by Schlumberger in 2008, and actively participating in establishing the International University Bremen, now the Jacobs University, Germany. It should also be noted that over the past 10 years, Dietrich has been striving for a less politically driven accent to the debate in Germany about energy and climate, and that he remains active and forthright in this endeavor. Dietrich's name is synonymous with basin modeling, having had the foresight to envisage its value in both earth science education and in the petroleum industry. Understanding the dynamics of earth processes, not the static end result, has been his quest, and his pioneering publications are classics. Earth scientists everywhere, in academia and industry alike, associate the name of Dietrich Welte with petroleum formation and occurrence, the first comprehensive textbook in the field of petroleum geochemistry. First published in 1978 with co-author and fellow AAPG honorary member Bernard Tissot, and expanded in 1984, this book presented an enlightened insight into the processes of petroleum formation, from basin through to molecular scales, and heralded the start of the discipline we know today. His efforts have not gone unrewarded. In 1995, he received an honorary doctorate from Bochum University, and he has been a recipient of the AAPG President's Award, the University of Oklahoma's Clarence Karcher Medal, and the Geochemical Society's Alfred Tribes Award, as well as the Karl Engler Medal of the German Association of Oil, Gas, and Coal Research. Dietrich also found time to mentor 80 master's degree students, 50 PhD students, many postdoctorates, and junior colleagues. Today, most of these are working for the international petroleum industry worldwide. To Dietrich Welte, geoscientist, entrepreneur, the father of modern petroleum system modeling, his contributions to geoscience have been both diverse and far-sighted. But out of all his achievements, it was the vision of rigorously translating chemical, physical, and biological process descriptions into source, seal, reservoir, and trap coordinates that was a game changer for modern petroleum geoscience.
And in winning the Sidney Powers Medal, Dietrich today is making a bit of AAPG history. It is his 5th AAPG award, placing him with Martin Jackson and Robert Weimer as the most honored geologists in AAPG history. Ladies and gentlemen, please join me in congratulating Dietrich Welte.
President, dear Ted, ladies and gentlemen, this is a very emotional moment for me. It's almost 50 years ago that I came to Pittsburgh as a graduate assistant when I was a Fulbright scholar in Penn State. And it was a time when in Germany we still had a lot to catch up. The economy was down and it wasn't easy to be a student. And the US and the AAPG gave me the chance to do things I could not have done otherwise. I would like to address two issues as a geoscientist. The first one is that the integration of the different geoscientific disciplines, I think, is a new way to do our scientific work in our profession. And what I mean is the application of computer modeling as an experimental tool to understand and follow up the very complex chains of processes in the subsurface. And I believe we even should aim at a new kind of curriculum in the geosciences that allows us to be, let's say, geoscientific generalists, because you need to know about the physics behind the processes, about the chemistry behind the processes, and of course, all the geological details. And the only way to do that, because we don't have experimental tools to do that in the laboratory, is the computers. Now, I realize that it is impossible for an individual to do all that together, and therefore we need teams, and we need the kind of education that allows whoever is in the position to do that to become a modern geoscientist, at least understanding computer simulation. So the integration of disciplines is really what I hope will develop further. The other issue I think is very important, and it is important especially for my own country, for Germany. That is the twin issue, energy and climate. And before I say something about it, I would allow myself to tell you what I had done in this respect. It was in the early 80s, and I was familiar with the carbon cycle. I initiated a lot of paleoclimate research at the research center. I was in several committees for the provision of energy, and I got a lot involved in the politics behind that. The research lab where I worked was originally a nuclear research institute, and I had been asked at the time to add the classical fossil energy. And then it became known, and that's a fact, CO2 is a greenhouse gas. And there are other greenhouse gases like CH4, water vapor, etc. I don't want to go into details. And then the nuclear industry used the argument of the CO2 as a greenhouse gas to promote their own nuclear power, which is correct. But one of the main arguments was CO2 is a greenhouse gas and it would ruin our climate. The basis for that were computer models. And I know computer models, that's the company I had founded. And then politics took over, the United Nations took over, and now we have on this sector a mess. And I would like to tell you a few facts which are not known widely. First, the Earth's climate history, paleoclimate research, has not found objective reasons that CO2 would play a decisive role. It plays a role, but how big it is it? The second thing is, during the period of the Silurian, and the geoscientists know that, and during the period of the Permian and the Carboniferous, we had big ice ages on Earth, but the CO2 level in the atmosphere was over 1,000 ppm. Today we have almost 400. So it was 3 to 4 times as much. And I think it has to be explained, why did we have ice ages with these very high CO2 levels? Second thing, what many people don't know, the man-made CO2 worldwide is less than 6% of the total natural CO2 cycle on Earth. And the sinks and sources for this natural CO2 cycle are very ill quantified. It's not possible to quantify it better than about plus minus 10%. And please remember, the natural CO2 is far, far bigger as a cycle than the man-made one. And the last argument I would give you is, over the last 18 years, the average global temperature is declining, but the CO2 is increasing. And in the ice core data, we know that it is always first the temperature that rises, and then the CO2 level. And this is understandable because the oceans, which cover 2/3 of the Earth's surface, would liberate the CO2 that is diluted in the ocean when it warms up. And secondly, the microbial degradation of the organic material increases, and therefore the CO2 levels rise. Now, don't get me wrong. I really want to preserve the environment. There are lots of problems with water, with organic pollutants, etc., etc. All that has to be taken care of. But the CO2 argument for the global warming idea has to be looked at very critical. And what I want is that the geoscientists are aware of that, and that maybe on an international way form a scientific platform without politics to look at this issue very, very critical. And if we are not able to do that, I see a problem for the credibility of the geosciences. Thank you very much. I hope I didn't speak so long.
No.